Alright guys, so this is the proof of Thales Theorem. Now Thales Theorem says that if you take any circle and you draw a diameter across it, which I did here, so the diameter in this case is from A to B. So I draw that diameter and I pick any point I like, C, on the boundary of the circle. Now if I make a triangle out of that, then the angle here, ACB, this guy here, or angle C, depending on how you want to name it, has to be 90 degrees. So we're going to prove that that's true. So the kind of key here is we're going to draw a line from the origin. Let me draw that a little bit better. From the origin to C. Now, if we think about this, what do we know? Well, we know that any line from the origin to the boundary of the circle, that's a radius. So we have the line segments OA, OB, and OC are all radiuses, or radii. Are all, oh, I spelled that wrong. Are all radii. So they all have the same length, which is the radius of the circle. So I know all of these guys are the same length, so I'm going to put little tick marks there. So what we got now is if you look at the triangle AOC and OCB, these have two sides that we know are the same. So we know that these guys are isosceles triangles, which means that they're angles that are where one line is the equal side and the other line is the not necessarily equal side. These angles here are equal. So that angle and that angle are equal. And this angle and this angle are equal. So that's pretty cool. Now let's add one more label. Let's call the angle here, let's call this X. And let's call on the other side, let's call that angle Y. So from here, we know two things. We know that the sum of the angles in any triangle has to be 180 degrees. So I'm just going to use the angle label for the measure of the angle just to save space. So I know that if I add up the measure of the angle X plus the angle A plus the angle A, so that's 2A, that has to be 180. I know on the other side, the right small triangle, I know that the sum of those measures has to be 180. So Y plus 2B equals 180. And the other thing that I know the angles here, X and Y, I know they're supplementary. So I know that X plus Y equals 180. So they are my three equations. I'm going to use those to show that this angle here, I need to show that A plus B is 90. That's what we're going to show. So we have our three equations here. And what we're going to do, we want to end up with, down here, that A plus B is 90 degrees. So one way we can do it is we can add equation 1 and equation 2 together. So these guys, remember, if we have two equations and we add them together, we get another equation. So let's do that. Let's add equation 1 plus equation 2. All right, so that gives us x plus y plus 2a plus 2b. That's the left-hand side. So it's going to be x plus y plus 2a plus 2b. And now let's add the right-hand side. We have 180 plus 180 is 360. Now, we know that equation 3 tells us that x plus y equals 180, since the angles x and y are supplementary. So we can use equation 3 here and substitute that in. So we get that, instead of writing x plus y, I'll write 180 plus 2a plus 2b equals 360. And simplifying that, we'll subtract 180 from both sides, and we get that 2a plus 2b equals 180. So here we're subtracting 180 minus 180 on the right-hand side, always doing the same thing to the left-hand side that we do to the right-hand side. And now, all we need to do is divide both sides by 2. And we did it. We got what we want. We got that a plus b equals 90 degrees. So that's Thales theorem. If you draw any triangle where the length of one side is the diameter of a circle and the other vertex is somewhere on the boundary, then you have to be drawing a right-angled triangle. There's no other way around it. That's pretty cool. So that's Thales theorem.